Yes. Ah, scheduled for 22nd August. Oh, sorry. Uh, yeah, so let's start the lecture. Wait, let me get it prepared. All right, so guess let's start the lecture. So today, this is quite an important lecture because it's SQL. So now we start with SQL. This is going to be important for your project because your project is going to use SQL. Okay, so we're going to talk about the basic SQL first, and after that, next week we're going to the more complex SQL construct. Now, while we're waiting for the rest, let's have a short coffee chat to know what we have so far. We start with this traditional data processing, which we claim was troublesome. Okay. It will be much more troublesome if I do not have the map or filter or even pivot. Okay. But I thought it was going to be too troublesome, so I just added these two because they're also already available in Python. And when we go into the relational algebra, there's actually a very nice relation between these two, is that map actually corresponds to projection and filter corresponds to selection. There's a reason why we call this selection, because once we go into SQL, to filter the table, you kind of have to use the select from where. This is your simplest SQL query. The selection condition will be put into the where. Projection, we say that for relational algebra, the projection is actually a limited form of map. So that's why I put map star. There's an asterisk there. For relational algebra, it's a simple, simplified form of map where you cannot actually add new columns. Now, in the case of SQL, you can actually add more columns. You can compute columns in SQL. Right, so the correspondence between the map and filter in the SQL is that you have the select here from where. So I'm writing it this way, and you will see later that the select will, on this part, you get your projection. And you may also get partially your rename row. This is a small part of it. If you want to rename your columns, you can use the renaming over there. The selection condition is put over here, so the sigma over here. All your relations will be put over here from the from. So that's the simplest form of SQL query. And then what we assume is that for relational algebra, all the tables are already available, and then they can be joined into universal relation. Later on, we will relax this condition. You need to be the one that ensures that all your tables can be formed into a universal relation. We kind of try to do this using what we call as a normal form, but that's still later. So where are we going from here? Now we are going to make our own table. So that's going to be the start. This is going to be your create table. Okay, but at this point, I'm just going to tell you what to create and all the constraints there. For your project, you will need to know what tables you need to create, how to ensure that the tables are created properly, and so on. And we will only going to discuss a simple query of a select from where form. Next, this is kind of added. I just had a group project registration set up. The link is given over here. So you can start registering your group. All I need is just one response per group. Okay. And for you know, I need to maintain your privacy. So for the case of privacy, you should never ever give your metric number. So what I want you to give me is your user ID that should start with E. Okay. So the deadline for this is the end of this week. If you cannot form 5 people, so if you have less than 5 people, by the end of the week, please also register your group even if you're alone. What I'm going to do is I'm going to do a random assignment or random merging. Okay. And there's a PostgreSQL installation. This will be our main SQL engine. So Postgre is one that is most conforming to the SQL standard. There is the PostgreSQL installation guide. If you want to use other SQL engine, then you can, but some of the features might not be readily available. Okay, so let's answer some of the questions from the chat first. One is that for tutorial, do we need to submit answers on cosmology? Okay, so the answer is no, you don't have to. The cosmology is only for you to practice. Okay, so it's fully optional. There's a comment. Metric number is non-confidential. Actually, this is not. Because if you think about it, your email is starting with E. If you have not set up your friendly mail, your email starts with E, so this one should be the one that is non-confidential. People will know because they can read your email address. Is tutorial participation graded? No. Okay, so I moved this to forum participation. So if you look back on the what was that? The lecture 0. Because tutorial if the tutorial participation is graded, then we may actually get the tutorial to be delayed for a longer period than we like. Okay. Oh, the assignment on Luminous. I think I have not updated this yet. So this one, because I thought I'm not going to use Luminous, so I thought all the data there is kind of already gone, but apparently not. Okay, is the training on cosmology optional, or it's optional? But it's a good practice, so at least you have some practice somewhere. So, yeah. So again, this is optional. Okay. Yeah, so the tutorial starts this week. Okay, so let's start. Oh, if you want to use others, so if you want to use other kind of SQL, you can, but some feature may be different. I already found a few differences, at least on the SQLite 3 that we use on Cosmology, but that's kind of like the best that I can have right now to set it up on Cosmology. You can also use MySQL, and there are certain differences in MySQL, so some of the features here may not work. In particular, for the case of triggers, triggers are I believe outside of the SQL standard, but it's kind of a good features. So yeah, for the lecture notes, it kind of follows the Postgre. Because if you try MySQL, you can also please install the correct MySQL, not this one. This one is a hand wash. I forgot where I get this. But yeah, so you can do other things. You can use other SQL, but again, just note that some feature may be different. Okay, so let's start the lecture proper. We're going to go through the syntax first before we go into the training. I know that I forgot to publish the training, so the training has just been published today. So we're going to go through the syntax slower, and then we go through the lecture training. So first, this is the general form of how you can create a table. The keywords is in dark blue. Okay, but some of the problem is that SQL is case insensitive. So you can actually use all lowercase, all uppercase, but try not to mix cases. And for easier reading, use uppercase only on the keywords. Okay, and typically what I also do is that all the data types should also be uppercase. Okay. And for everything else, use all lowercase. Okay, I mean that's just a convention that we try to follow, just to make reading easier. Okay, but the important thing is do not mix the cases. Okay, don't do it like this. Some of the important things that you may miss is that the semicolon, at least for PostgreSQL, the semicolon is important. And once you declare a column, you end with a comma. Okay. If you have multiple constraints, so if this is the constraint number 1, and you have more constraints, then you also use comma to get your table constraint number 2. But for the very last one, before the closing bracket, there are no comma. Okay, this is a common source of errors. So please be careful with this. Okay, so for the data types, there are a lot of data types. I think I also gave a summary in the training. These are some that you may want to use, and the The idea is that if you really want to make it very, very sensitive to the amount of storage space that you have, try to make it as small as possible according to your specification. Okay, so for instance, if you do not need a double precision, then you can simply use float 4 if you want. Okay, the 4 here means it's 4 bytes. If you think that integer is too big, then you can use smaller data types. Okay. For things like numbers, like money, maybe it's good to use numeric with a specified number of digits and maximum of fractional parts, where the fractional parts is kind of 2. All right, and for certain things where you know that for string, like where you know that the length is fixed, for instance, your metric, it may be better if you just use char instead of varchar, because it is actually also faster to retrieve those values. So if you use the correct data types, not only you can get a smaller database size, but you may also get a faster query. All right. And there's a question: the data type size is different for different database. For certain common ones, let me just put it here. For certain common ones, it's quite standard. But for others, it can be specific to the database engine. Okay? So yeah. And there's a question, are these data type keywords for Postgre? That I'm not exactly sure. But try not to use this for, don't use for your table name or attribute names, if that's what you're concerned with. If you're concerned about the uppercase or lowercase, then just use uppercase for data types. But basically, don't try to do funny things. Okay? Don't try to abuse the system, try to break the limit, because we'll try to go within the specification instead. All right, now here I put timestamp, but you can actually separate the date and the time. So there's date, as you can see over here. There's also time. If you combine them, some SQL keyword uses the date time, or like Postgre, they use timestamp. In some cases, they may be equivalent instead. The other thing that is not really apparent from this all data types is that the values here, for all the types, it includes a special value of null. All right, so please try to treat null as carefully as possible, because you know the behavior can be weird. So yeah, there's null. You can always put null. All right, so next. So this one goes for the column constraint. So we're going to discuss column constraint before we discuss about table constraint. Column constraint typically checks only on the given column. Okay, but again, so take this with a pinch of salt. It typically checks on the given column, but not always. The thing about SQL, one of the basic principles of SQL is somehow be permissible. make it easy for the programmer. If you want to try this out, but again, this is not really exactly a good practice. The reason why I say it's not always is because of the check. The check keyword here is a general constraint, and for some weird reason you can actually check a different column than the one you are actually giving it now. Okay, so a quick example, if you want to know about this, is that let's say create table test, and just for simple one, attribute one integer, and here I'm just adding more here. If you're using the check, for some weird reason you can actually check A2 and A3 in the same column as A1. Why is this so? I do not know. Okay, so be careful with this. And yeah, so I was quite for this one I was quite I was wondering whether to put it here on the column constraint or not, but I'm just putting it here because you can put it as part of the column constraint, but you're actually checking another column. Okay, now there are a few common ones here, so that there can be others. The common ones are just primary key. Okay, so recap. Primary key is a chosen candidate key. And references is for keywords. Right? And for certain things like when, okay, so we'll talk about foreign key later, but this is just the good practice, is a suggestion. You give the table and the column. Okay. The next one is the uniqueness constraint, and the last one is the not null constraint. There are some that is not so common, which is the null constraint. Again, this null constraint is basically just the not null, just remove the not. This is actually doing nothing, because by default you allow null values. Okay, again, I do not know why it's there, but if you missed on the not, it will be accepted, but again, it basically do nothing. Right, so let's answer some of the question first. Can you check if a value exists in another table? The answer is yes. Okay, one of them is through the foreign key. That's why it's called the inclusion constraint or existential constraint. But basically, foreign key constraint check if a value exists in another table. If you're talking about a more general thing, then you probably have to use trigger, because all the constraints that we are currently looking at right now only looks at a single table except for the foreign key constraint. Right? Then the next question is it sensitive to indentation? No. Okay, but again, good practice to have proper indentation. There's a question on, is it bad practice? I guess this was referring to check A2 less than A3. Then the answer is yes, definitely. This is a pretty bad practice. Don't try to do this, but I'm just telling you that it's possible. Yeah. There's a question on what do you mean by SQL be permissible? This one means that try to allow as many possible syntax as it can. Okay, so that's basically what it means. So even though some of the syntax may be kind of, you think it may be malformed, sometimes SQL actually accepts it. All right, so let's continue on first. Oh, actually, there's one. There's one that's interesting. There is a keyword default. In the textbook. That means if you do not give the value, when you insert, the default value will be used. Okay, so you can say things like A1 integer default -1. Okay, which means that if you do not give what is the value of A1, then -1 will be used instead. That's what the default means. Okay, so let's look at the next kind of constraint, which is the table constraint. This checks for the given table. Okay, again, foreign key, you check if the value exists in another table. Now, the main difference between the column constraint and the table constraint is that this is the only way you can specify primary key or candidate key containing multiple attributes. When you say that it is part of the column constraint and you say that it's primary key, notice that we do not give the column. The column name doesn't exist here. Okay, so let me erase that first. Just not to confuse. Okay, so in the column constraint, when you describe a primary key, then it is the column where you are actually giving it that becomes the primary key. But if you want to specify a combinations of a few columns as your primary key, then you have to use the table constraint. So similarly for the foreign key constraint, and notice that there is an additional keyword over here. It starts with foreign key. You specify that this collections of columns is a foreign key, and it references another table for that particular collections of columns. In this case, the number of columns must be the same. The name need not be the same. That's why I use column A, and this one is column 1. But you basically have to say that M is equals to N. Otherwise, it will not work. Okay. Then there's unique. This one means that the given tuple, so all the values specified by this particular columns, is unique. What do we mean by unique? That means that if any of the values are different, then it's not unique. Okay, so it's kind of that all values must be the same, then it's not unique. Wait, sorry. If one of the values, okay, yeah, this one is wrong. This one is wrong. Okay, so I'll update this later. This actually specifies that this is not unique. Unique means that one of the value is different. As long as one of the value is different, then it's unique. This one actually specifies not unique. Okay. Again, the check can also be present there. For the table constraint here, you can optionally give a name to the constraint. And the way you do this is that you say constraint. So constraint is a keyword, and then you specify the name, constraint name. and then you put one of this constraint over here. Okay, so this is table constraint. So you can specify a constraint name, that way you can refer to the particular name, or if you get an error, the error will give you the constraint name. Right? So there's a question, does the ordering of the specified columns for the table matters? Yes. This one, yes, absolutely. And then there's a, what is the actual difference between unique and primary key? Okay, so this one we will discuss later actually, because primary key is a chosen candidate key, but what happens if you still have other candidate keys and you want to check for that? We can represent primary key in another way. But the main difference over here is, again, as someone said, is primary key cannot be null. All right? Here, you have to be very, very careful, because I put a note on SQLite 3. Specifically for SQLite 3, for some weird reason, they allow primary key to be null. Okay, I don't like this, but that's what they're doing. Right? And then there's a comment here. I think you can have more than one null in a unique column. Yes. Okay, so this is because the way you check uniqueness is that if any of the values are different, then it's unique. Okay, but again, our main principle is that we reject on false. So we need to find a constraint that says not unique. By reject on false, what we need to do is we need to find a condition for not unique. So if you have A, B, C, A1, B1, C1, and you have A2, B2, C2, how do you say that they are not unique? To say that they are not unique is basically A1 equals to A2, and B1 equals to B2, and C1 equals to C2. Now what happens if one of them is null? Then you get unknown. Okay? So this must be satisfied, or because we kind of invert it, we say that this is not unique. And by the Morgan's law, we can do this. And as you can imagine, that if one of them is null, then you don't get false. Okay, so that's a unique. Okay, so let's look at primary key. Now, this is, if you have a primary key constraint, it is actually just a kind of almost shorthand for this. So primary key means that the value that you have must be non-null and must be unique. Okay. Now, why do we say that primary key is unique and not null? Okay. So again, we try to derive this. We look at a particular column. We use so you have A, B, C. If A is the primary key, what will happen? We want to uniquely identify B and C given A. So if A is given, we want to uniquely identify B and C. But how do we do that? what we want to prevent is that A cannot uniquely identify B and C if we have things like A and then B1, C1. Okay. Think for a moment what this means. If A is a primary key and you allow this two into your table, then it violates the primary key of the key property of A, the primary key property of A. So we want to prevent this. We want this to be not allowed to be inserted if this already present. So what can we do? Well, the easiest way is that we say that A here must be unique. We can simply prevent this one from being inserted because A already exists. The alternative is actually harder because the alternative is that you check that these two are the same for a given A that is already available in the table. Okay? So the easiest way to prevent this row from being inserted is to just check that the primary key itself is unique. Now, why do we want the primary key to be not null? This is a kind of a separate matter because you can have a lot of complications when you're dealing with null, like, you know, null equals null. What will you do in this case? If you allow the primary key to be null, as you get in SQLite 3, what will happen is that if somehow, somewhere in the middle of your database, you set it to null, or the primary key is being set to null suddenly, will you allow that to be set to null or not? Okay. So again, the easiest way to deal with anything involving null is typically just say that it cannot be null. So that's why we want them to be unique and not null. Okay, now, foreign key. I think some of you mentioned in the book errors forum that I wrote it wrongly. Okay, so yes, there's but I have not had time to modify the book yet. I'll probably try to do it by tomorrow. But here's the thing. Okay, for foreign key, if A refers to B, then B must be candidate key. Okay, it need not be primary key. It can be simply just a candidate key. All right. That's basically the specification. Okay, and this is the reason allowing it to be candidate key instead of just full primary key is the reason why the keyword that we use is references the table and the column. Right? By allowing candidate key to be referred to in foreign key, we need this. In particular, we need to specify which column it is, because the column need not be a primary key. The column can simply be a candidate key. And a table can have multiple candidate key. If you only allow it to be primary key, then a table can only have a single primary key, then we don't even need the column, because it's kind of clear what are the primary keys. Okay. Now, SQL actually kind of relaxes this condition even further. It not even need to be candidate key, but it's just unique. As long as it's unique, it's fine. Okay. So we will not go into this in details, but our convention is that what we want is eventually that when you have a foreign key, what you are referring to should be candidate keys. Okay? Preferably primary key, but if you are referring to candidate key, it's fine. We try not to go into just unique, because then it will be difficult when you have the null values. Right? So yeah. There's a question, if the candidate key is allowed to be null, then how does the foreign key on table A uniquely identify? Okay, this actually is an interesting question, but the full answer to this is kind of in the ER diagram. So at some point, when you talk about relationships with an object or relationship between objects, if you have A, if you have an object of type A, and then you have an object of type B, and you say they are related. So let's say a student enrolled in a module. Right? So a student is an entity. Enrolled is a relation, and then a module is an entity. Right. So here, the candidate key. Oh, candidate key is not allowed to be null. Okay, so this one is not. But the foreign key is allowed to be null. I read this one wrongly. Okay, this one I misread as this one's supposed to be foreign key. The foreign key is allowed to be null because at some point you may want to actually merge the two, like this. Okay, but that's in the ER diagram. For the candidate key cannot be null. Because candidate key also should satisfy this. We use unique, not null, to also denote a candidate key. The value at A can be null, but the value at B cannot be null because B must be candidate key. Foreign keys are nullable, yes. That means you do not know if you want to refer to something else. So candidate key cannot be null, but foreign key is allowed to be null. Okay, and if you have a pair, so again you can generalize this to any kind of tuple. If you have a pair that refers to this other pairs, then this other pair must be a candidate key. Now, one of this can be null, or both can be null. The reason for this, the one that I found, is basically it says that if any one of this is null, then it's treated as a null tuple. Right? Yes, because okay, so there's a question. So a candidate key and primary key have the same restriction. Yes. What is a primary key except there is a candidate key that you choose? Okay, so this is the definition that we say. Primary key is a candidate key that is chosen. The only difference between primary key and candidate key is that primary key is chosen. The other restrictions are the same. And how do you choose primary key from candidate key is up to you, whichever one is more reasonable. All right. This is arguable. If you say that you refer to, if your references allow only unique, then it can be null. But again, that's why we do not want to do this. Okay. So the thing that you're referencing cannot be null for our purpose. But it can actually be null, but it complicates a lot of things. Okay, so try not to go into this. All right. Okay, so let's move on. When you are referring to a foreign key, so A, let's say we use this to say that it refers to B. Some attribute A refers to B. B can be in another table. B can be in its own table. It need not be unique. It need not be different. So you can refer to your own table, when A refers to B, a few things can happen on B. One is that you can update the values that is being referenced. So what will happen on the A? So we can do a few things. You can cascade. Cascade means that if you update on B, whatever value is referencing that value on B is going to be updated as well. Okay. If you cascade on a delete, if it's deleted on B, the value that is referencing those values that are being deleted is going to be deleted as well. Okay. There are other things like set default. So if you delete it, then you can set it to the default value if it's given and if it is possible. Because if the default value is null and you say that it's not null, then you cannot set it to the default. In which case, then the deletion will fail. So again, similarly for set null. This one is basically just making it to be null values. All right. So let's attempt this one first. So I've already published this this training on cosmology. So I'm giving you a few moments to try this before we discuss the answer. In the meantime, we will just we will answer some of the questions here. Okay, if foreign key can be null and candidate key cannot be null, then how does foreign key even access? So again, there's no access here. What we are saying is that foreign key, so if A kind of refers to B, there's two conditions. One is either the value exists as candidate key in B, or the value in A is null. You are not accessing it. So what is happening here is that you can say that I do not know yet whether this value exists in B, but once I know for sure, I want you to check that it is really exists in B. Okay, so that's kind of the meaning that the value in A is null. It makes certain things easier if you allow this. Otherwise, you cannot even insert to A unless you are very, very sure that you have already inserted in B. Okay. There's another question. Must foreign key be unique? No, foreign key need not be unique. Okay. So foreign key can be duplicated. Okay, and then another question. What is the practical difference between unique and candidate key? This again, it depends on the. This depends on the SQL engine that you use. Okay. But for primary key, more often than not, there is a practical difference between just unique, and that is indexing. Indexing means that when you try to search for a certain value, primary key is most definitely going to be used as part of your indexing. So think of it this way. Primary key is going to be unique and not null, right? So if the implementation of the SQL is a hash table, when you want to search for it, there can only be one key on the hash table, and that is typically just going to be your primary key. If you just say unique, then it's typically not going to be used as your key at all. So the practical difference of primary key and the rest is it depends on the implementation, but for the rest it's not. Even if you implement it, so this you can probably learn this in the CS3223. There's a B tree implementation. The B tree implementation will also require certain key to be used to separate the child of the tree, and that is typically used using primary key. Okay, so there's a practical difference on primary key, but for the rest, there's not much difference. Okay, so let's try the creating tables. Oh, let's just resume. I actually already have the answers over here. Student view. Okay, so let's look at the questions. We want to create a student table, and then we are given the following order, and then you have to apply the following constraint. Okay, so what can we do with this? Well, let's use this. How do we answer this? Let's say you do not know what is the question, what is the answer yet. How do we reason about this particular question? Well, first, these columns must be given in this particular order. So you can just simply say create table. Okay, and the table name is students. And you can just start with the simple skeleton. Okay, so first create simple skeleton. Okay, and then you just put in the name first. And then you figure out the rest. Okay, so here variable character, because I did not give how many characters there should be, you can actually use varchar if you want. Or if you're really say that you want to get as many characters as possible, you can also use text. Okay, it's kind of fine. Okay, so varchar, we use varchar. And then for the S name, we also use varchar because it's a variable character. For the intake, it's an integer, so we just do this. Now we look at each of these constraints, and then we apply it to the columns that we have. So every student is identified by their metric number. Okay, so this, they must be identified by this, so we kind of put primary key. And then we're done for the particular column. For the student, it cannot be null, then we just say not null. And for the intake, it must be greater than the year 1900 and cannot be null. So it's null. And also check intake greater than 1900. Okay. For the last one over here, you don't give the comma. Okay. If you do not like the check over here, you can also put the check over here as a table constraint. For this particular question, if you try it on cosmology, because of the difference in the SQLite, primary key in SQLite can be null, so that's why I use not null over here. Okay, that's just the simple difference, but for our purpose, if you're using SQL, or if you're using PostgreSQL for your assessment and your project, you do not have to do this. This is specific to just, yes, not now. This is specific to just SQLite, and this one should probably be integer. Okay, so that's the first step is always create simple skeleton. The second step is to fill in the column name. And third, just fill in the constraint. So that's going to be how we are going to solve this. All right. So the second question, modules. There's a question, why is the intake null? So that is a typo. It should be not null. Okay. So there's a typo in Q2. Oh yeah, this one should be modules. Hopefully Q3 is correct. Yes, Q3 is correct. Okay. So again, how do we try to solve this? So again, create simple skeleton. Remove this. Fill in the column name, mcode, Sam's, mname, and credit. The module code is a variable character, so we just say varchar for simplicity. An integer, so integer. Varchar, and the credit is also an integer. Okay, so that's the second step. Right, so now you have this. Every module is identified by their module code and semester. So the keyword of identified kind of implies that it should be primary key. Okay, so there's a module code and semester. So these two should be primary key. But again, it's two attributes, so you should put it as a table on string. Okay, this is what I did over here, primary key, mcode, and sems. The module name cannot be null, so you put not null. Semester can only be 1, 2, 3, or 4, so you can check that sems is greater than or equals to 1 and sems smaller than or equals to 4. All right. The m name is done. The credit, the module credit must be between 4 and 5. There's a lot of ways to do this. You can say credit is equals to 4 or credit equals to 5. Okay, because again it's between these two and it cannot be null, so you just put not null over there. Okay, and then you just put comma wherever you need, and you're done. And this is a slightly different one, so greater than 3, smaller than 4, smaller than 5. It's also a smaller than 6. It's also a valid way of checking. I'm putting not null on the mcode and the sems because again this is SQLite. Okay. So yeah. So let's attempt the third one. This is the simplest one out of all. You create the table lecturers and then you just give this. So again, the reason why this is not null is because this is SQLite. Okay, so let's try to answer some of the questions first while you try the question 4 and question 5. One of them is this. Is the semicolon essential? Okay, so this is probably easier if I show you on Postgre instead. So you can have PSQL over here. So let me try to make this large. This is what's going to happen if, oh wait, that is not going to be well. This was for the first table. For Postgre, I can just do this. If I do not have a semicolon, in Postgre, it doesn't know that you have finished. Okay? Only when you put the semicolon, then it knows that you have finished. So it is critical for Postgre. So again, it's a good practice to use semicolon. The next question is, Can I use this instead of typing n? Actually, this one I'm not sure because I think it depends on your SQL engine. Okay. For check clause. Okay, so this one I kind of also forget. This might also depends on your SQL engine, but I guess this one will work as well. I'm not sure whether this one is actually acceptable or not, but I believe so. But you can also do this in SQL. And then there's this, is there a need to put n in varchar n. This, again, this I think we discussed this, and it's good if you are very concerned about the size. Okay, so I don't have that right up. If you're very concerned about the size and you want to check that the length cannot be exceeding certain length, then you're probably going to need to put n. Okay. But again, I think some SQL engine doesn't really check the n anyway. But for Postgre, I believe they do. Right, so let's try question 4. Now question 4 is getting more interesting because now we have foreign key. So now we assume that the students, modules, and lecturers are already defined for you, and you need to create a table teachers. Okay, so again, we create the structure like this, fill in the attributes, fill in the types. What you need to be careful of in this particular case, because you are referring to something else, the type of LName, because it's going to refer to the teachers table, should preferably be the same, or at least interchangeable with this. Can be a restricted subset of it. So if this one is text, you can actually put varchar over here, but preferably they are of the same type, and that kind of prevents weird errors later on. Okay, so once we do this, then we add the constraint. Each row is identified by the LName, module code, and so on. Okay, so this primary key and SEMS. Okay, the lecturer name must be in lecturers. So references, lecturers, LName. Now again, as a best practice, these two should be the same. Okay, again, this is just best practice. As much as possible, try to make it the same. If you're referencing something, you should give it the same attribute name as well. For this particular instance, you don't need this. You are allowed to just do this because there's only one candidate key in lecturers, so it's clear which one you are referencing. But again, for best practice, is better to do this. Okay, and then the pair of module code and semester must be in module, so you can put this foreign key, mcode, SEMS, references, modules. Again, you can do this because the pair is there, but for good practice, you do this. Okay, so then for the rest, you just put the comma, except for the very last one. All right, now there's a few questions over here, so try to attempt question 5 first while I try to answer the question. I think someone tried for PSQL, it's 1. Okay, so yeah, so note for PSQL, for Postgre basically, checking equality is using this. instead of this. And there's a question is this the same? Well, this is actually my syntax for relational algebra. Okay. So for SQL, you should use OR. Okay, so you have and or not. So let's this one. So this one is and. This one is or. I think I use this. This one is not. Right? So yeah. Now there's a question. This one refers to the top one. Do we need to put foreign key? For this one, you don't need, because this is a column constraint. Okay, column constraints just say that, well, it knows that you're going to make this to be the foreign key, so the foreign key can be ignored over here. All right. So yeah. So again, this one is a column constraint, so you know which column you are referring to, and the column that you're referring to is this al name. So if you say that it's going to be a foreign key, then you don't have to specifically say that it's going to be foreign key. Okay. Another way, you can also use a table constraint. So this is table constraint. You can do this. This is fine, but this is a table constraint instead of a column constraint. All right. There's a question: if the default value is not used, if the default keyword is not used, the default value is null. Yes. The default value is always null. It's one of the reasons why we have null. Okay, so let's erase this, and then let's attempt the last one. The skeleton is this and rows. The columns are metric, lname, mcode, Sam's grade. The types are varchar, integer, varchar. Okay, so now we put in all the constraints. Each row is identified by this series. So we put primary key, metric, lname, mcode, Sam. Metric number must be in the students, so metric references students metric. The triple must be in somewhere. Mcode and Sams. Okay. Okay. For this, I put not null almost everywhere because again it's what is required over here. I think this one there's a yes. This one is a. You can even put this in a different row. So this one is fine if you want. You can put it in a different row. It doesn't really matter. So yeah. So that's it. That's how you can create the table. So let's try to answer some of the question here. Earlier, it was mentioned that SQL is case insensitive. But when I tried Q1 and wrote all caps, I pass all the public test case. That means you have something wrong in your in your creation, I believe. Because you can pass the public test case, that means yes, it is case insensitive, right? That means the problem is not with the case sensitivity, right? Yeah, so it is case insensitive because otherwise you will not be able to pass the public test case, right? There's a question, metric number must be in the student table. This is what we did, references students metric. It must be there, right? If you references, then it must be there. This, and together with the fact that it is part of the primary key, that means the metric number cannot be null. Okay, so it's a mix of those. Change to all lowercase, then you pass all private test case. Okay, so that one I'm not sure. It could be SQLite. This is a continuation. This could be SQLite 3 problem. So let me show you over here, because here we know that it's students, right? So let's drop this one. This is how you remove a table. You drop the table. Yeah. So let's recreate this. Okay, and then so just give you a brief look at the selection. So select star from students. So this is lowercase, it works. Okay, it should the case should not matter. Right, so that's it for the table creation. We will discuss how you can create a good table, how you can design good tables when we talk about ER diagram. Okay, so now what we want to talk about is how do you modify the table. Okay, the first keyword here is alter table, but we don't really use this because, again, this one is not typically used. So I'm just going to go through it very, very briefly. It's not going to be typically used because once you set the table, the property will not change unless you update your specification after your database has been running. After your business has run, basically. So now, because your business has already run, you cannot just remove all the data, right? So you can just alter the table if you want to add more columns. This one is actually should be dropped. Or you can add constraint, or you can drop constraint if you want to relax. Okay. Right, now, this is how you can insert into a table. The simplest syntax is this. If you do not specify the ordering, so this is specifying order, then you use the default order. If you specify the order, then you use this order. Okay, that's basically the difference. When you try to insert, then it will check all the possibilities, or all the constraints. There is one more that I did not put here. If you want to insert multiple tables at this, multiple rows at the same time. So let's say I want to insert multiple values at the same time. You can do this. So I think metric, say A1, it's for simplicity. The name is A, The intake is 2000. Now, instead of using semicolon, you can use comma. If you use comma, then you can specify another value, A2, B, 2001. Specify another value, A3, C, 2002. Then you put semicolon. Column A1 doesn't. Again, so this is another thing that you need to be careful of, is that I keep on forgetting this. Postgre or SQL uses a single quote. So a single quote means that it's a string. A double quote is apparently used for something else. Right, so let me show it to you over here. So here you can do this. You can insert multiple rows at the same time. Okay, so this there's a comment. You can actually use this for both. You can use this for Postgre. You can use this for SQLite. So this is the one that we kind of prefer. You can also check it like this, right? So select then it concatenates. And it also works in the SQLite. Okay. There's a comment again and partially question. Are the commas needed? Because this is yes for Postgre, but somehow SQLite 3 is weird. Okay. Do not use SQLite 3 as your benchmark. Okay, now this is how you can remove from a table. So again, the difference between removing rows from table and just removing the table itself is that if you say delete, you want to remove from the table, so it's delete from. If you want to remove the table itself, it's a drop. So that remove the entire table. Okay. For updating rows, again, you can also use the condition there. The keyword is update. This is the keyword, and then this is what you want to set. Okay. So the meaning of this is that for everything that satisfies this particular condition, you set the column name to be whatever the expression is. And here, if you have a column x, you can increment by 1 by doing x equals to x plus 1. All right. So this is the asking from a table. This is for the queries. This is the simplest form of queries. And I'm showing you the relational algebra correspondence. Okay. So you select. Now, to fully correspond to a relational algebra, you need to use the keyword distinct. Distinct means that you will remove duplicates. In relational algebra, you do that automatically. Okay? So the table, you can specify multiple tables, and they will be combined using a Cartesian product. The condition here, which I will explain later, is part of the selection statement. The keyword as over here is optional. You do not have to use this. But if you use it, then you basically can do a renaming. Okay, and these are the kind of operations that you can do, which include for the conditions. Okay, so this I took this from the Postgre. So this is Postgre standard. At the very least, you know, it's a Postgre standard. You can do this, a simple arithmetic. These are bitwise, so please be careful with this. This is not conjunction. This is not disjunction. This is a bitwise operation. That means if you have 1 and 2, you get 0. Okay, so it's not a conjunction. It's a bitwise operation. A few things that are quite interesting is that you actually have this symbol, which kind of try to mimic square root. So it's a vertical line followed by a slash. If you want to have a cube root, it's a double. Okay, and there's the absolute value. You can do this, and you can even compute factorial. I don't know why. And yeah, so these are all the rest. And a few other things is that you have and, or, and not. Okay, so that's how you can form your operations. Okay, so let's try to do this on a real example. So first, the student info. So I'm giving you a few minutes to try this out. So I'll be back. Okay, so let's discuss this. Let's see. I have not seen this. Oh, apparently you have to submit 3A to open 3B. Okay, so I think it's some old issue. Let me just remove that particular condition. Okay, so now you can try this. I think there's quite an urgent question over here. How to attend tutorial? Is my TA supposed to send me a link? Okay, so here, this is quite interesting. If you haven't seen your link yet, you can go to Luminous, and then you can look at the conferencing. If the conferencing has already been set up there, you can see it for your own group. If you are already assigned to a group. If you are somehow still If you're somehow still under appeal, then unfortunately, I think you have to wait a while. Okay, so let's try the first one. There's a lot of things that you can ignore from here. The main thing will be find all students' name in the university. So first, how do we answer SQL query question? The first step that you need to do is find where the informations are. Yes. This is one way. This is the SQL way. The other possibility is that you can always do the relational algebra way, which is to figure out the relational algebra query and then convert to SQL. Okay, so this is another way. But we're doing the SQL way. Find where the information is. Right. Second one. So this, to answer this, you basically ask which table or tables. Okay. And then ask, is there any condition? Or before that, you can ask which attributes. 3, is there any conditions? So if you do this, once you answer all of this, then you can create a select from where. Okay. Usually what I do is I indent this so that it looks nice, but you don't have to. But it's just to make things look nice. So which table? So we know that all the students' names are in the students table. So you put students here. So this is the answer to question 1. Which attributes? We know there's the S name. So this is the answer to 2. Now we don't really have any condition, so we just remove it. Okay. So this is the minus minus is how you put comments on the SQL, but it comments until the end of the line. So, but we don't really need this. If you do this, then you can answer the question. Okay, and don't forget to use the distinct, because it says that you need to remove any duplicate names. And we know that there are duplicates. So if you don't use this thing, you will get wrong. Okay, now let's look at the second question. Again, we do exactly the same way here. So this is only for the simple one first. So select from where. Find the name of all lecturers that teaches at least one module. So again, we need to know which table. Now it's not just lecturers, because the lecturer must teach at least one module. Okay, so the table that you need is actually teachers. Okay. If you accidentally use the lecturers, I think the public test case you can solve it, but this one you won't. I think some of the private test case you won't be able to solve. Okay, so the teachers table is the one that you want because you want the lecturer to teach at least one module. And the attribute is the name. So the attribute is L name. So again, distinct L name. And we don't really have any other condition, so we are done. So that's how you solve the second question. The third question is the modules info. I believe this is one where we actually have where. So again, the structure. Which table do we need? Okay, so find all the code and the name of the modules that is offered at least on semester 2. So we need to know the modules that are offered in semester 2. So we need to know the modules. So the table is modules. Okay, so again, for the simple SQL query, just answer these 3 questions. Which table? In this case, just the module table. Which attributes is the code and the name? So you need to know the code, which is M code, and the name, M name, that is offered at least on semester 2. Okay, so here where SEMS equals to 2. Okay, this is at least, because as you know, this is 2 and 1. If it's only on semester 2, then you need to do a kind of a intersection. But we'll deal with that later. Now we'll deal with the simple one first. Okay, so the condition is that it is at least offered on semester 2. Okay, so if there's one where the semester 2 is available, then you take that one, ignoring the rest. Okay. The fourth question. Here, the module title is the concatenation. So we define something. We define that the module title is a concatenation of module code and the module name. What we want to find is the module title offered in semester 1. Okay, so this one should be at least in semester 1, so we do this. It's from the modules. Now what we need to do is we need to concatenate these two. And we refer back to the set of operations that we can do. There's a string concatenation over here. So we can do this. Okay, so we need to concatenate this with at least one, with a space in between. Okay, so this is how you concatenate. There's a question here, an interesting one. This is basically about the choice of word. What does at least SEM2 even mean? There's SEM1, and there's SEM2, and there's SEM3, and there's SEM4. Okay, this is NUS. These two are special SEM. Formally, they are called SEM3 and SEM4. Now, if a module is offered in SEM1 and SEM2, then you should display that. Because another way of phrasing this, so this is another way of phrasing it, but this is different question, is basically saying that only in SEM2. If you say that it's offered only in SEM2, then you cannot just say that you cannot solve it easily. Because if you say SEMS equals to 2, you will also get something that's offered in SEM1. Okay, so the wording has to be very, very precise. This is why I choose at least in SEM2, because there are other SEM. It can be offered in other SEM, but at least it must be offered in semester 2. Okay. If I'm asking you only in semester 2, then it's a different and harder problems. For question 3, should there be two distinct? Here you kind of need to differentiate. When you say distinct, this thing should come before any series. Then that means everything here, in this case it's a triple, is treated as distinct. Okay, so there's the distinctness is this entire triple for this particular case is treated as distinct. We look at this. After the projection, the triples that are not unique will be made unique. Okay, so but you only have one distinct over here. So if you want to do something like this, first, I haven't tried this, so I am not sure if it is a valid query. Second, if it is a valid query, I think what it meant is that each will be unique. Okay, so there's a different kind of meanings here. Okay, so let's continue on with this because we have done the concatenation. So let's look at the last one, which is how to get the student grade. Now here, what we want to do is we want to deal with null. There are special operations where you can do to deal with null. Yeah, you can use the standard equals, not equals. For the not equals, there's an alternative, which is this. So these two are the same. You can use this. But when you talk about null, there are other operations that you can use, and those are is null. This is to check if the given value is null. Okay, so true if null, else false. And then you have is not null, which is the opposite of this, false if null, else true. There's the one that I discussed at the very end of the first lecture, which is null is distinct from. So null is distinct from null is basically false. It's kind of like your not equal, but null is treated as value instead of null. Okay, so now here we want to get everything that is where the grade is still null. So again, we do the SQL way. So select distinct from where? Which table do we want? So this one we want to get the students that are enrolled. So students that are enrolled. So it's in the enrolls table. And we want to find the metric number. So this one is metric. There's a enroll table has a metric component. And we want to check that the grade is null. Okay. And we want to know that the student is actually enrolled in CS2102. So this is how I usually do it. And enrolled in CS2102. So M code equals to CS2102. And it's in semester 1. So it's supposed to be SEMS. So this one is a typo. I will correct it later. And SEMS 1. Okay, so that's how you kind of figure out for simple queries how you can solve this. You need to ask yourself 3 questions. Which table? Which attributes? And is there any conditions? Okay, so that kind of concludes our lecture. So I will stop here and I will start answering questions on the live chat again. If you have any questions, you can ask in the live chat. But you can also feel free to leave if you have to prepare for other lectures. Okay, so there's one question. Let's follow the question here. Why is the bracket not necessary? You can put the bracket if you want to be confident, but the brackets are not necessary. So the question is why, right? So if you look from a programming language perspective, what we will have is basically something like this. You look at keywords, so select from where. Okay, so now if I put bracket or not, I know that the set is done as soon as I encounter from. So from a parser perspective, there is no difference between having a bracket here or no bracket there, because I know that as soon as I encounter the from, then I'm done. The set of attributes is finished. Okay? Now again, one of the key principle here is that SQL is trying to be permissible. So it will basically just accept with or without parentheses. Okay. There's a question. I believe this one is referring to this. So again, the simple answer is no, but we also want to know why doesn't it work. The reason why it doesn't work is because now this is where the selection condition is treated differently from the constraint. Okay, so remember this. When we want to check constraint, we check on false. When we look at the conditions, we accept on true. Okay, so it seems like it's a simple question, but it has a very good underlying principle that we need to differentiate here. One is that for constraint, you reject on false. On conditions, you accept on true. Which means what happens with this is that if you say A or A plus equals to null, the result of this is null. It's not true, so you do not accept. Okay? So yeah, so this is a very, very excellent question for this. So any other questions? If you look at this, also I have this particular let's open with Notepad++. I have this. You can actually run this on your Postgre. This is just basically a copy paste from the answer that I have for each of the questions, but so some are kind of unnecessary like this. The start is I delete all the database first. You can have an optional keywords of if exists here to check. If it doesn't exist, then it doesn't give you an error. This is just to ensure that this create table will give us the correct table. Because if you accidentally already have all these tables in your Postgre, then I cannot create this. And if you make it in the wrong way, then it will not work. Okay, so one of the first conditions that you probably want to have in your SQL file for your project later is that to always start with a drop table. So try to drop as many tables as you can from your database first if you want to reset everything. Then there's this principle, you do it in the reverse order of creation. Okay, and there's a good reason why. So let me just answer this, and it's actually quite fun, is that you have references, right? You cannot delete a table that is currently being referenced. You have to delete all references to it first before you can delete a table that is being referenced. Okay, so because you need to delete the referencing table will definitely appear after the creation of the reference table. Then you have to delete in the reverse order. Okay, so the way you use this, at the bottom you can insert the test data also. So the way you do this is you can just copy the entire thing, open your Postgre, and then just paste one big insertion. and you can just select star from students. All right, so this is how Postgre display it. And yeah, so that's you can try it on your Postgre if you do not want to do it on the cosmology. All right, so any other questions? Okay, so if there's no questions, then let's just close the lecture. So I'll end the stream soon. But if you still have more questions on it, you can just put it on the live chat. Then I will answer that. Or if you don't have time anymore, then I will just basically put it as a update on the lecture notes. Okay. So yeah. So thank you for coming. So I'll see you again next week.